Okay, now I'm going to talk about the microcontrollers. Okay, first of all, the microcontrollers are computational tools and computing machines were always the attraction for technology implementation in the field of automation for industrial and domestic products. Automation being one of the objectives of the computational needs were the motivation for the development of computing machines and devices. Well, today microcontrollers have become an integral part of all automatic and semi-automatic machines. For example, the remote controllers, the handheld communication devices, and dedicated controllers use microcontrollers. Well, microcontrollers are single-chip microcomputers more suited for control and automation of machines and processes. Microcontrollers have central processing unit, or the CPU, memory, input and output ports, timers and counters, analog to digital converters or ADC, digital to analog converters DAC, serial ports, interrupt logic, oscillator circuitry, and many more functional blocks on a chip. A single microcontroller IC can directly get the analog input, say in the range 0 to 5 volts typically, from a temperature sensor and drives LCD display. Note that there is no need to connect any external memory. The ADC function is also built inside a single microcontroller IC. Another important class of processor is the so-called bit-slice processors. The term bit-slice processor means that the processor can be interconnected to form a processor of a desired word length. Bit-slice processor consists of an ALU typically of 4 to 8 bits, registers and control lines. Uh, Here is a picture of an ALU. Now let's talk about the architectures. There are two major classes of computer architectures, namely hardware architectures and the von Neumann or Presentaiton architectures. Many special designs of microcontrollers or DSP (digital signal processor) use hardware architectures. Hardware architecture uses separate memories for program and data with their independent address and data buses. Because of two different streams of data and address, there is no need to have any division multiplexing of address and data buses. Now let's talk about the arithmetic unit for data processing. But first here is a picture of the hardware and Neumann architectures. The ALU or arithmetic and logic unit performs arithmetic and logical operation on 8-bit operands. Accumulator is the register which gets the output of the ALU in most of the arithmetic and logical operations with few exceptions, apart from addition and subtraction operations. Also performs multiplication and division operations. Each of the logical operations involves digital gates, and or not exclusive OR operations are possible. The arithmetic unit comprising is a comparator circuit which takes as input first data as comparison reference data and second data as data to be compared with said first data, and performs a comparison between said first and the said second data. When said first and said second data match as the result of said comparison, outputs a value 1 and set a match signal active. And when said first and said second data do not match, output set a second data and set said match signal inactive. Now let's talk about the program and data memories. There are two separate program and data memories. The code is typically stored in ROM or the EEPROM. The program storage is one of the factors that differentiate among the various members of the microcontrollers. Another devices have the program memory EEPROM of 4K. Data memory can be internal RAM and off-chip external data RAM. Internal data RAM, for example, in the 80C51 is 128 bytes. Now let's talk about the inputs and the outputs. Well, each programmable input or output pin has a programmable IOV having buffers for compatibility with the TTL and the CMOS signal levels. It can be used as an input, an output, or a bidirectional port. An IOV that is configured as an input can have direct latched or registered input. In an output configuration, the IOV has direct or registered output. Now let's talk about the relation of the components inside of the microcontroller. Well, in the following image, there is a diagram that shows us in a simple way how the elements inside of a microcontroller work. Due to the time given to make the video and to avoid making it longer than expected, I am going to skip the explanation of it. Besides, the diagram was made clear enough to understand without an explanation. Now, let's talk about the spreadsheet. First of all, we have the date, that is the date when the microcontroller was made. Then the transistors is the number of transistors that it has. The microns, that is the width of the wires, and the thinner, the more transistors the microprocessor has. Then the clock speed, frequency, and the data with amount of info. Well, now let's talk about how they were made. There's a distribution of pins, electric parameters, memory capacity, inputs, and outputs. Well, the pins are what stick of an IC and connect electrically to the outside world. Ports are represented with register inside the microcontrollers and allow the program or the firmware to control the state of the pins. I hope you enjoyed the video.